Hello everyone. Today we'll be doing the experiment on tetraphenylcyclopentadienone synthesis. I know that it is a mouthful, but I hope you guys will have fun watching the video on synthesizing it. So here are the materials for the experiment. There is a water-cooled jacketed condenser, there's a 3 ml reaction vial, and there's a spin vane. So these are the things that we need, so let us begin. So first reagent to measure out is benzyl, and we take 0.1 grams of benzyl for this synthesis reaction. Then we transfer the benzyl into a 3 ml reaction vial containing a spin vane and then set it aside in a wooden block. Then we are going to weigh 0.1 grams of 1,3-diphenyl 2-propanol. So this reagent has a solid liquidy gel-like structure that tends to clump. So it takes some effort to place the measured amount of this reagent onto the weight boat. Transfer it into the same reaction vial containing benzyl. So this reaction vial now contains two different reagents, benzyl and 1,3-diphenyl 2-propanone, along with a spin vane. Then we pipette out 1 ml of absolute ethanol using a pipette and a measuring cylinder and transfer the absolute ethanol into the same reaction vial. After that, we bring our reaction vial containing the reagents along with the spin vane back to our fume hood and attach the jacketed condenser with the two necks or outlets for water in and water out. We also attach rubber tubings, the ones that are colored in black, just for the water to pass through. Please remember that the outlet at the bottom is for water in and the outlet at the top is for water out. We switch on the heat and the magnetic stirrer. So we are going to wait in this stage for about 3 or 4 minutes or so until all the solids dissolve. So by the way, the magnetic stirrer and the heat is still turned on, and when all the solids dissolve, we are going to add ethanolic potassium hydroxide. So we are going to add 0.2 ml of ethanolic potassium hydroxide, and we are going to add it through the tube inside the jacketed condenser. And if you go back to one of the first slides, you will see that there is a tube that runs from the top to the bottom. So 0.2 ml of ethanolic potassium hydroxide. Measure out 0.2 ml of ethanolic potassium hydroxide using a mechanical pipette and slowly add it to the reaction mixture drop by drop. Note down the change in color. After addition of ethanolic potassium hydroxide, the color changes significantly. At this stage, we increase the temperature of the hot plate and reflux it for 15 minutes. After refluxing for about 15 minutes, we switch off the heat and remove the reaction vial from the heat source as shown, and let it cool to about room temperature. After the reaction vial cools down to room temperature, we carefully detach the reaction vial from the jacketed condenser and transfer the reaction vial into the ice bath. We need to be careful about placing the reaction vial into the ice bath because of the chances of falling over. So we need to be placing it in such a way so that it doesn't fall over. Once the reaction vial cools down enough, our TA Goshu is scratching on the walls of the reaction vial in order to help with the crystallization. And once enough crystals have formed, we are going to perform vacuum filtration in order to retrieve the product. This is what the product looks like right now. Next, we use 95% ice cold ethanol to wash the spin vane, the reaction vial, and the glass rod. This is done to collect all the product. This rinsing process is repeated a few times to retrieve as much product as possible. Once all the product has been transferred into the Hirsch funnel, we are going to let the product vacuum dry for some time. And so while the product is drying, we are going to weigh out an empty vial as shown. After the product is dried for 5 to 10 minutes, we are going to transfer the product from the Hirsch funnel into the empty product vial. After all of the product is transferred, the mass of the vial with the product will be taken. So this is what the tetraphenylcyclopentadienone looks like. Our next characterization is to take the melting point of the product. So we are going to poke on our product with the melting point tube. Then we are going to drop the melting point tube a few times through the rod. This is to make sure that all the contents collect at the closer. Next step is to collect the melting point, and we are going to, as we have done before, we are going to place the tube in the instrument, and then we are going to run the instrument really fast until it hits the temperature that is close to the literature value. And yeah, so this is running really fast, and the melting point needs to be reported over a range. Here we are going to let this melt for a while. So once we hit a temperature that is like closer to the literature value, so around 20 degrees less or 10 to 20 degrees less, we are going to slow the instrument down. Now we have slowed the instrument down to 6 degrees Celsius per minute increment of temperature. And the sample has started to melt.
After we have performed the experiment, we need to clean all the glassware and our bench and our workspace and the fume hoods as well. And we need to first rinse the glassware with water and then with acetone. And that takes everything that cleans up the glassware pretty much very well. And then we need to dispose of the liquid in liquid waste and the solid in the solid waste. And if there's any broken glass, we do it and then we dispose it off in the disposable glass container. And the melting point tubes also go to the disposable glass container. So that was it. So that's it, guys. We have performed this experiment of synthesizing tetraphenylcyclopentadienone. We have characterized the products, the mass of the product, and as in the mass of the vial plus cap, mass of the vial plus cap plus product. So you can figure out the mass of the product. And then we have taken the melting point, and we don't need to take the IR. That's it. Thanks.